Now let's move on to our next topic, regular expressions. Regular expressions are patterns with special markups or meta characters or syntax that match a certain string sequence. The power of regular expressions is its ability to generalize an infinite number of string sequences using just a combination of few special characters. In Linux, you typically have few frequently used meta characters that you would embed into a regular expression. A star or an asterisk means it matches any character. A dot means you would like to substitute that single location with just one single character. You can also specify a range of characters as well. In this case, in case you want to specify a range of uppercase alphabets, then you have an option of doing so using capital A and uppercase Z. Or you can also specify a range of digits to go from whatever number that you would like to range between. In this case, I'm ranging between 0 through 9, which would count all the numbers from 0, 1, 2, all the way through 9. You can also specify a certain pattern by requesting that pattern to be matched either at the start of a line using this caret symbol, or it can be at the end of that line using this $sign. So this means that you are requesting for those lines or rows in a file that start with a certain pattern. You can also request for those lines and rows in the same file or another file or a collection of files that end with a pattern. Next interesting topic, which is traversing and navigating a Linux file system. Before we do anything, let's go ahead and do a clean slate on our terminal using the clear command. Before you start to navigate around a Linux file system, it is essential to know where you are currently located. On most of the Unix-based operating systems, the default location where you land after logging in is called the home directory. The system administrator of that specific machine would have configured the home directory locations to be having different paths. By default, on most Unix and Linux machines, /home/ your username would be your home directory. If you are a Mac user, you would have noticed /users/username would be your specific home directory. In order to know where you are currently located, there's a command called pwd, which stands for the present working directory. And that command can be executed and it will inform you where you're presently located within your file system tree. So let's go ahead and execute. Of course, you will start off with what is to know what it really does. It tells you, it prints the names of the current working directory. Let's go ahead and execute it. You can see that I have a different kind of a file path here because I created this just for the short course. So you are, in your case, if you are within your home directory, this result will be /home/ your username on that specific account. Navigating the file system or moving to different directories on a Linux machine can be done using the cd command. Cd, as it stands for change directory, will help you change the working directory here. cd is the basic navigation command for moving from one directory to another directory. You could be doing a cd to a location which is at the root of your Linux, right? So you're doing a cd into your usr directory, and when you do your pwd, it's going to list you that you're moved to a different directory altogether. Or you could also move into a subdirectory, and in order to do so, you have a command called ls that's going to list all the subdirectories of your current directory. Now you can say there are a few directories in here and we have few files. We'll take a closer look at the ls command at a later time, but for in order to understand the way you traverse Linux file system, the cd command is something that you should be using. So you could go into a subdirectory here by name bin, and when you do your pwd, it's going to list the complete path of your directory tree. Now you moved into the cd first, and then you further moved into the bin directory. But you can see that you executed two separate cd commands. You did a cd to user, and you did a cd to a directory called bin, which is contained within the user. In Linux, you don't have to really break your commands into subcommands. Rather, you can always give it the complete path where you'd like to get relocated to. So here you can do a cd into my parent directory, which is the usr, and that's a child directory by name bin, which is contained within this usr directory. And now when you do your ls, it's going to list there's a lot more of files and folders within this user/bin directory. And in order to go back to your previous directory, you can always do a cd space dot dot, which is going to take you to your previous directory that you visited, or previous directory in your directory tree or in the path. Now it is taking you back one step above, which is the usr directory. You can always do a cd minus to get into that previously visited directory, which is your bin directory. Or if in case you want to go up multiple levels, you can always do a cd dot dot cd and dot dot, which means that you're moving up 2 levels here, and you'll go back to the root of the file system, which is the slash. All right, moving further, let's look at how do you work with files and folders on a Linux machine. In any Linux machine, there are different kinds of files. One is the ordinary file, you have the special files, and you have directories. Regular file contain, or your ordinary files, they contain text, data, and software codes, or even compiled programs. You'll have special files that are reserved for the system level operations, like configuring your Linux environment, files that act as links to other files, or even alias files. Then you have directories that contain ordinary files, special files, and even subdirectories. As we've seen under the user bin, we notice that there are a few folders and files that are contained within that. Firstly, in Linux, once you are in a shell, you would want to see what the contents of that current directory is. So the ls command is going to let you take a look at all the contents of that specific directory. You can always give the ls command a path to a directory structure. In this case, I requested the ls command to print all the contents of the user bin directory. By default, the ls command output does not differentiate a file from a folder or a file from a directory, or it does not tell you what each of these files contain, or even the type of files. Are these ordinary files or special files or directories? You can always refer to the manual page of the ls command to see if there is any special options for you to demark a certain file as whether it's a separate or an ordinary file or a special file or a directory. So let's take a quick look at the manual page for the ls command. So here you can see the ls is going to list all the contents, and -a is going to, it's not going to ignore any entries. It's going to pretty much show you everything, including all the hidden files and folders. And as you scroll down, you can see that there is a -f option in here that could be used in order to indicate whether a file is a special file, a directory, or an ordinary file. So let's go ahead and use this -f argument or option to the ls command to see how the results get formatted. So I'm going to use the ls -f option, and I'd like to see what's under the user directory. So here, the formatting of all the contained folders and files or look a little different. You can see there's a slash which is added to all these directories here, bin, etc, games, all the way till source, meaning these are all directories. The slash at the end of a file name means that these are directories. You can see an ampersand at the end of a TMP file, and this means that it's a file. In order to know more about these files and folders, and to know who created them and when was the last time these files and folders were modified, you can always specify few specialized options to this ls command. In order to learn those, you can always go visit your man page for that specific command, and we'll see what option is available for us to have detailed description about every single file and folder contained within a certain path. We're going to use an option called -l, and the description for that is it's going to do a long listing formatted version of the regular ls command. I'm going to clear my screen. You can always go back to the previous visited command. I'm going to replace my uppercase F with a -l. Let's see what happens. Now it clearly states that there are a bunch of files in here, and the ownership of the files, the person who created it. Of course, these are all created by the root or the administrator of this account. And it also tells extra information about every single file here. So in this case, the TMP file is actually a link to another file which exists at a different location. So hence the reason why when we did the ls -f, it had this special @ at the end of the TMP directory, indicating that it's a symbolic link to another file which resides at a different location. You could always combine multiple options. So you could always do -l, and you can always combine the F option together with the -l option. You don't have to specify. If you need, you can specify -l -f, but since you're combining all these options together, I will just make it like L and F together, and then you can specify a certain path. Well, here it's going to show you the long listing way that is enabled by the L option, and the capital F option is going to overlay the classification information on every single file and folder contained. So here is an example of a very complex command where you have utilizing several options available for the ls command in order to format the output the way you want it to be. Now let's move on to the next section, which is to view the contents of a file. Since this section involves viewing contents of an existing file, we've created a quick test example or sample file that you can download from the table of contents page for this specific video session. The name of the file is test.txt that we'd like for you to download first. And I've done that already. So when I do my ls command, it's going to tell me that this file already exists. You can always look at, since you just learned about the -l option, you can just type that, and that tells you who's the owner of it, which is myself here, and I belong to a certain group of users on this cluster. And you can see the last time this file was modified was the 28th of September. And you can always do the other command that we just learned a minute ago, which is using the -f to overlay some classification information for you. All right, the file we have test.txt. You'd like to know whether this file is something that can be read on a Linux terminal, or is this a specialized file? So there's a special command called file in Linux that you can use to check whether a certain file is formatted in a human readable format, or is it binary, or if it needs further post-processing for you to look at the inner contents of that file. To do so, of course, you can always do your what is command to know a little bit about this command of your interest. So you can see that it tells you that it determines the file type. So let's try this file command on our input file, which is the test.txt. So in the above command, it returns the result ASCII text, which means that it is human readable. If you do the same command on an executable, like the ones that are stored within your user bin location, it gives you a different answer altogether. Well, this file by name ls, which is contained within the user bin path, is actually an executable which is compiled for a 62-bit operating system and for this specific version of the Linux. So you can clearly see that since this ls file is an executable, which means that it is a binary natured file, you cannot look at what's inside this file. But since our example file is an ASCII file, you can always look at what's inside that specific file. In order to view the contents of a file on the display screen, also called as the standard output, so this is your display screen that you're looking at now, you can always use a command called head. Head is a command that would output the first part of a set of files. In this case, you can say head test.txt. The head command reads the first few lines of any human readable text file or data and writes the output onto the standard output. In this case is the terminal. The default number of lines that a head command would print onto the screen is 10. But you have an option of overwriting those default options that go with this head command. In order to learn a little bit more about all the options available, you can always use the man page for the head command. And you can clearly see that there is an option available and it takes an argument. So this option -n can be overwritten. So you can do a -n, give it a different number, and it's going to print those many lines, those many top lines in a file. By default, it's the top 10 lines that gets returned. So let's go ahead and execute that. So we're going to do a head. We're going to print just the top 5 lines in this test file. The opposite of the head command is the tail command, where you like to look at the last few set of lines in a file. So the tail command operates similar to the head command. You can see that the tail command took an argument, which is the name of the file, and it's reporting to you the last set of lines contained in that file. You can always restrict, overwrite the number of lines that you would like to see. In this case, I'm going to just show only the last 3 lines in that file. So this gives you an example for looking at the contents of a file. Why do you need to look at the contents of a human readable file? Well, you might want to know how the data is formatted. In case if you want to write some codes on this data file, you would like to know how many columns you've got, and you would like to know which column contains the information that you are interested in. So typically head, tail, these are a few commands that you would start off with when you are doing any data related operations. Just like the head command, you have another set of commands called more and less. The more command is one of the family of Linux commands called pagers. Man more will give you more information about it. More will let you read through a text file page by page. In this case, a page is defined as how much of content that can be shown onto your display terminal. So you could be minimizing or reducing the size of this display terminal, and accordingly the amount of information shown on the screen is either going to get diminished or it's going to get amplified. It's going to reduce the amount of information that gets thrown onto the screen. And the manual page is an example of a pager family of commands, because it's going to show you one page at a time, and then you'll have to use the space bar to advance to the next page. So let's try out the more command on this file that we have as example here. Here you can see, well, since we do not have too many lines in this test file, it's able to show all the contained lines on the screen. Let's assume this test file had few thousands of rows. Then how many ever rows can get accommodated on the single display screen will be shown part of your first page. Then you'll be using your space bar to advance to several other pages. One of the drawbacks of the more command is you won't be able to go back and forth. So in other words, the page shift operation is one page at a time moving forward, and it does not have better searching capabilities. And in order to circumvent this problem, they've come up with the less command. The less command is going to work pretty close to the more command, and it also tells you when the file has actually ended. So in this case, it has clearly indicated that it's end of the file. But if you had a file that was much bigger, it had a lot more lines, then you can see the less command will come much more handy than the more command. Again, these are 4 different commands that will let you take a quick glimpse at what the human readable file contains. Again, head, tail, more, and less. Now let's move on to the next section, which is manipulating files and directories in Linux. Creating directories. For creating directories on a Linux or Unix-based platform, you use a command called mkdir. So mkdir is going to let you create one or more directories with just a single command line operation. So within our directory of interest, or the directory where we are currently, we'll check and see if there are any subdirectories here. So the ls command has not returned any subdirectories for us. So let's go ahead and create a new directory here. So the mkdir temp is going to create a new directory by name temp, and you can always use your ls command to make sure that that directory is created. In case if you want to create multiple directories within a same top level directory, in this case I have my top level directory as session 1 Linux primer, you can always do mkdir and give it all the names of the subdirectories that you would like for to be created. So in this case, I've got 2 subdirectories, temp1 and temp2, to be created within my folder of interest. And typing ls is going to show all the directories that we created with our previous commands. So here is a quick way of creating one single directory, temp, and here is another way of creating multiple directories within the same top level directory. Linux, the make directory command utility in Linux, is also going to let you create all the child directories. So you could have the temp as the parent directory, and you can create a child directory. In this case, if you look at the contents of the temp directory using your ls command, it's going to list that there is a child directory that we just created within the temp directory. But the default operation of the make directory command is going to assume that the parent directory exists. For example, if I would like to create a new parent and child directory, say temp4, which doesn't exist before, it's going to complain. The reason being, since the temp4 directory is not yet created, it's telling you that the child directory cannot be created now. So how do you really work around this problem? So I always say you can go to your man page and see if there is an option which is available for you in order to work around this problem. So there's an option -p that you can exercise, which does not return any error, and it can make the parent directories when it does not exist. So let's go back to our previous command using our upper arrow and just specify this -p option to create all the parent directories and the child directories. Now the previous command, which failed in the absence of -p option, now ran successfully. So here is one way of creating all the child directories and the parent directories using the -p command. You can re-execute the same command, and it's not going to complain that the temp folder or the temp directory already exists. So it can override that operation, and if a folder or a directory is already created, it's not going to do any harm to that folder or directory. Now let's take a look at how you delete files and folders using the rm command. Rm command has several options, and it has to be exercised with caution, because once you delete a certain file or a folder, it's gone forever, and it depends on how the system administrator has configured your Linux file system. It could either move to your recycle bin, in this case it could be your trash, or it can permanently be destroyed. So in order to remove files and folders, you can use rm command. Before I'm about to remove my sample text file, which we need for the rest of the training session, let's go ahead and use a command called copy command, cp, and make a copy of this test file, right? So I'm going to copy it into a new file, test2.txt. So the copy command is going to take an input file and copy all the contents of the test command into a new file by name test2.txt. You'll notice that the test2.txt does not exist prior to running this copy command, which is okay. The copy command is going to create that file first and copy the contents of the test file into the test2.txt. And let's make another copy of it too, just to show that way we'll have more files that you can remove using the remove command. Now let's do a ls to see how many files you've got. Now you've got 3 files, test2, test3, and test.txt, and you've got 4 folders or directories, temp, temp1, temp2, and temp4. Let's try a remove operation on the test file, right? Let's go ahead and remove the test2, and you can supply multiple file names to your remove command. So I'm going to remove 2 of the test files that I created using my copy command, using an rm command. And let's do ls. You can see that those 2 files are removed. And we just learned about regular expressions, right? So let's go ahead and exercise that as well. So if you have multiple commands that have some form of a file name sequence or a pattern in them, you do not have to list all those several commands or several file types one after the other. Rather, you can use a special character or a meta character, which is part of your regular expression package, and just with one option or one file name option with a regular expression in it, you can go ahead and remove all those other files. Let's make copies of the same test file. I'm just adding an underscore here. That's the only difference between the previous way I created and this way. So I have 2 new files, and I'm going to show you how to use regular expressions in a remove command. So you can do a rm test underscore. You could either do a 2.txt space test underscore 3.txt, or you could just do a star, which is a wildcard, which means that you can have any letter or digit replaced at those spot. And this command with this regular expression asterisk is going to get resolved into these two options in here, and it's going to remove these two files that exist on the file system. So here is one quick way of using regular expressions as part of your Linux command line operations. Now let's move on to removing directories here. When you're about to remove the temp directory, right, it's going to complain. It's going to tell you that a remove command cannot work on a directory because it is a directory. So you need to specify some options to the remove command in order to remove directories and the contained subdirectories. Always go back to your man page and see what options are available. Remove empty directories, right? So you'll use the -d command, option, along with your remove command to remove directories. Let's see if that works. Remove command with the option -d, temp1. It says directory is not empty. Let's see what's inside this directory. Does it have any contents? Yes, indeed. It has a child directory. What that means is a remove command with the -d option cannot work on directories that have subdirectories in it. And that's what the remove command's -d option clearly specifies. It can remove only empty directories. But if you have directories that have files, folders inside, or subdirectories inside, then you need to do a recursive remove. So let's try out this option now to see if it can recursively remove all the inner contents of that specific directory of our interest. So let's use a combination of the -r option and -d option on the temp directory. -r, -d, and now it works successfully. So this is a quick way of removing files and folders within your Linux file system tree. Of course, for you to remove something or modify something, you should have access to those files and folders. And most importantly, you should have the permissions to do those operations, because these are very expensive operations that are irreversible. So let's go back to how we had it originally. So let me go ahead and remove all the other directories that we created. I'm going to remove all the temp. Well, I could do a temp1 space temp2 space temp4, or I could do a quick regular expression star, which is going to remove all my temp directories. And you can see that we've gone back to where we were initially, or prior to the start of the remove command operations. Let's move on to the next section, which is renaming files and folders on Linux. So there's a command called mv, which is to move, which is nothing but analogous to a relocate, or making a copy of one file, except that the cp command is going to still preserve the original file, and it's going to give you a new copy of the original file. The move command is not going to keep the original file. It's going to go ahead and just move that file to a different name or a different location. So to do so, let's go ahead and do a quick copy. Well, we'll start out with the copy command. That way we always keep copy of the original file, and that way we can always come back to it. I'll call it _1. Now we have two files, and I'm going to create a new directory again, temp, and I'm going to do a move command. I'm going to change the name of the test_1.txt to test_new.txt. Here you go. Now you've got the new file. So you moved the file name from test_1 to a test_new using the move command. Now let's try to relocate this file to another folder. So we just created a new directory by name temp. Let's use the move command to relocate this newly created file into a new folder or a directory here. So with this move command, you can change the name of a file or a folder, and you can also relocate a file of your interest into a new directory that you have access to. In this case, we moved that file into the temp folder. Now let's go ahead and do a clean slate on the temp folder or temp directory. Since it's a folder and it has some inner contents, you need to do a D to remove a directory, and in order to remove recursively all these subfolders or subfiles, you need to do a R, which is for recursive, and just do a temp. All right, now we are back to where we are.